Okay, good afternoon, students. So we will continue our lecture from the previous slides, right? That is next. So one of the questions is today. Hello,
Sir,
everyone
your
can.
voice is cracking.
এবার বুঝতে পারছো? এবার শোনা যাচ্ছে?
Yes, sir.
Now can you hear me?
Sir, খুব low.
Yes, sir.
Hello. এবার বুঝতে পারছো? Hello.
Yes, sir.
ঠিক আছে।
আচ্ছা, ঠিক আছে। Okay. Now, one of the, do anyone have an idea how does an operating system start? How does an operating system start? Any one of you have any idea?
What, sir?
Sir, your voice is breaking. Idea about what?
How does an operating system boot up or they start running? How does an operating system start running? Hello. Anyone of you have any idea? বলো কি হয়? হ্যালো, আমাকে শুনতে পাচ্ছ তো সবাই?
স্যার একবার রিপিট করবেন?
How does an operating system start or boot up? Very simple question. I have a very simple question. How does an operating system boot up or start?
If we switch on the device.
That is the initial state, right? Then what happens? Acha, why do you see initially when you start the operating system, does it switch on like a television?
No.
No, right? Even your mobile, when you start it up, does it immediately show you the mobile screen?
No.
Why? What happens there? Why is that delay?
Because it's load things.
No, wrong answer. Anyone?
Okay.
বুটিং হয় ফার্স্টে, লোডিং না।
Okay. Now, why Sonia's answer is little bit misguided answer? I'll not say it wrong. So basically, when you are starting a television, what happens? What happens basically? The input of the television is from the satellite, right? Right, Sonia?
Yes, sir.
Or the input from the radio is from the All India radio station. Now the thing is that you just have to switch on the system or the television system or the radio, and it just telecasts what it is previously, what is being telecasting in the real time, right? But when you are starting your mobile device or when you are starting your computer, it is all basically what you can say. It is an all system within itself. It is the broadcaster, it is the presenter, it is everything that is within that same system itself. Now, supposedly the channel that you see on your television, sometimes it gets hacked. So what happens in there? When it gets hacked, what happens in here? It takes certain time to boot up all the systems. Same thing in the operating system. When you are starting an operating system, it has to load everything from initial. Now, what is the important word that I used in here is basically load. Acha, what are the other form of memory that are present in a laptop or a computing system?
Sir, you can you just slow down? I could not understand what you said.
System that is there in the laptop or your desktop other than RAM. বুঝতে পারলে কোশ্চেনটা? Do you know? The other memory is called ROM. Have you heard about ROM? Have you heard about ROM? Read-only memory.
Yes, sir.
Yes, sir.
So what happens in here in the read-only memory, the initial program to start the operating system is written, and it is a system that cannot be erased. That's why it is called read-only memory. You cannot write into it. You can only read from it, but you can only write into it, and it cannot be erased. It is basically what you can say. It is a non-volatile memory. That means if you switch off the current also, the information that is on the ROM that stays. So it is hardware code, right? So what is the purpose of this ROM? The purpose of the ROM is to store a small program called, it is there, or it can be in the operating system also, or it can be in the basically the hard disk also. So hard disk and the ROM are basically what you can say are the non-volatile storage systems, right? And the ROM stores a very small program that is called the bootstrap program. Now, in the modern days, that bootstrap program might be installed in the hard disk also. Both are non-volatile systems. Now, what is the purpose of the ROM? So, the purpose of the ROM, it points to the location within the hard disk, that is with the hard disk, where the operating system kernel lies. So whenever you are starting initially you have started your Android system, or you have basically you have started your desktop. So what happens? ROM basically locates or it knows the address where the kernel of the operating system or the kernel of the Android operating system lies, and it is what is the purpose of this program is it loads the operating system kernel into the memory or to the RAM, right? And it is one second. Okay. Now, what it does is basically it loads the operating system kernel from the hard disk to the main memory. What does this? Initializing the what if the bootstrap program, it starts initializing all the device controllers, all basically all memories, all basically initiates the device charger, everything it is initializes, right? And when it initializes, finally you see it initializes the graphics driver. So what should be your graphics screen? It initializes where the mouse monitor should lie, on which part of the screen. So these things are initialized by the basically the bootstrap program and the initialization. So finally, when the operating into your RAM, finally see your screen. And what it happens at that time, it waits for an interrupt. Interrupt means any user or system driven signal, right? So if you are now asked to do something, means if you want to start a player game, it will basically generate an interrupt to start your system. Have you understood this one?
Yes, sir.
Yes, sir.
So why does now the question is, now why is right? It is not an easy task. So it is all things are within that operating system itself. So it is the initiator, it is the starter, everything it does by itself. So that's why it is important. That's why the startup, you should know how the computer system basically starts, right? So the bootstrap program can be within the ROM also, or in specialized cases, the bootstrap program can be within the hard disk also. So basically, the address of the bootstrap program is basically loaded into in the case it is a ROM. So it is loads the operating system kernel from there, or if the bootstrap program is in the hard disk, so it loads the particular operating system kernel from a particular memory hardware memory, or the secondary memory address or hard disk address where the operating system is located. Now you understand why it is very understood why the computer system is slow to start up, right? It is not like a television system.
Yes, sir.
Okay, fine. Now we are talking about multiprocessor system. So initially in our days when we used to code, we have Pentium 2, Pentium 3, Pentium 4 chips. So those were basically single processor unit systems. Means those desktops had single operating system. Now, what it happens in here is basically if you are now this was basically single processor system. The systems in earlier days were little bit slow. But currently, what is happening in here, we are using multi-processor systems. So what happens in here? So nowadays you see that the computer now, if you are working on a what you can say that is two-core system and three-core system, if you have worked on both the systems, you will understand that the three-core system is much better than the two-core system, right? It is working much faster than the two-core system. So basically what it happens in here is that the computer programming cycles, right, are basically there is a computer program and the number of computer cycles required to run that program in a single processor. Let us take a number. If there is a if a program takes 100 processing cycles, if a program takes 100 processing cycles to complete, right? Now in a single processing cycles, it will take total 100 processing cycles only. But if we add another processor to it, if you add another hardware processor to it, now that 100 processing cycles can be divided by two CPUs. In that case, what happens? The timing is also half. So the timing initially required how much? 100 seconds. Let us say it was one processing cycle takes 1 second. But if it is divided into two systems, two CPUs, CPU cores, then it is divided by two, that is 50 processing cycles. Right. Now, if it is 50 processing cycles, the time must be also 50 seconds. So the single processing system takes 100 seconds to work, but the multiprocessor or the two processor core systems takes what we can say around half of that or 50 cycle times. You understood this one?
Can you repeat this again, sir?
Acha, let us understand this one. So you have a single CPU system, right? So you have a computer program and it requires 100 cycles to complete, right? So there are, let us say, one computer cycle represents one instruction. Your program has 100 lines of code. So each program takes, each program line takes 1 second. So it is 100 cycle times, right? But there is a single CPU, right? So single CPU will take how much time? 100C into 1, sorry, 100C divided by 1, it will take 100 seconds only, right? Let us say 1C is
Yes.
equal to, let us take 1C is equal to 1 second. So if the 100 cycle CPU is taken by one single CPU, it will take 100 by 1. So 100 seconds it will take, right? But in here, there is a, basically what we can say, this is two CPU systems, right? This is CPU 1 and this is CPU 2. Now in this case, there is again, the job is again 100 seconds, right? Now the job is divided into equal halves. So 50 lines of code will be run by CPU 1 and 50 lines of code will be run by CPU 2. So in these cases, the time required will be lessened by. So 100 divided by 2 will become 50 seconds or 50 cycles, right? So initially it took 100 seconds to work for a single job. In the second case, we see it takes only 50 seconds to complete this job. Understood? এটা বুঝতে পারলে?
Yes, sir.
Yes, sir.
But এখানে একটা ব্যাপার আছে. What is the thing in there? The thing is that you have to divide the job of 100 seconds into two CPUs. In that case, we can take, there are 10 computer cycles are required for division work. So these 10 cycles of work, we can call them as overhead. Okay. So we can say it takes only 60 seconds or 50 seconds, but actually it takes more than that because of the overhead. Now you understood what is the difference between a single
Yes,
core and
sir.
multi-core systems. So the job time becomes half. So you can work double. So basically, if the CPU has an integrated memory controller, then adding CPUs can increase the amount of memory addressable in the system. So basically, if the memory controller is there, so basically if this CPU has also memory controller, this CPU 2 has also has memory controller. So basically, it increases the amount of memory addressable in the system. So you can add up more memory in the system. So basically, a multiprocessor system allows processes and resources such as memory to be shared dynamically among various processes, and that can lower the variance among the processes. ঠিক আছে? So it allows processes and resources to be dynamically shared among the CPUs. ঠিক আছে? So all the it can be this job can be a operating system job also, it can be user job also. So multi-core systems, what it allows? It allows division of labor, right? For effective working. Understood? বুঝতে পারলা?
Yes, sir.
Yes, sir.
Now, when you are talking about, so this was about multi-processing system. So you should remember the terminology. This is what? This is multi-processing system or multi-processor system. It can have multiple cores. Now we are working on multi-programming systems. So multi-programming system is different from multi-processor systems. You should remember, this is very, very common questions, right? They may ask you at the time of interview. If any time they ask you what is a multiprocessor, what is the difference between a multiprocessor and what is a multi-programming. So multiprocessor means more than one processor. You should remember that. And what is multi-programming? Let us see now. So multi-programming increases CPU utilization by organizing jobs so that CPU always has one task to execute. So at one time you see that when you are playing a game, right? So it might happen during your, basically if you are studying right now only. So some of you, so not all of you, some of you maybe maybe you are listening to the lectures, maybe honestly another reading something else, Maybe you are also playing a game also. So all things are happening in parallel. It might happen. I'm not saying that it is happening right now, but it might happen. Or we can take another example. Supposedly you are multitasking. You are watching a basically you are watching a video also, right? And you are basically writing also something, right? All together in the same computer. You are watching the video, also you are writing something. But these two tasks are working simultaneously. So even if it is a single processor system, even it's a single processor system, you can do this. You are doing two programs at one time only, and you are thinking, how is this possible? And you are thinking, how is this possible? I am running two programs, and the computer is running both, and I know it's a single processor system. How is this happening? So the answer is that the CPU or the computer, the operating system allows multiple programming. Now, what is the multiple programming? So multiple programming, so basically initially when any program you want to run, it is loaded into the memory. And from the memory, it is loaded into the CPU to run. So what is a multi-programming operating system? Multi-programming operating systems allows multiple programs in the memory. So your writing job and your video watching as well as listening to the video is happening simultaneously because both of them exist in the memory. Okay. Now we'll ask the question, but the CPU can only work only one time only. So it can work only one job only, right? But sometimes when you are writing, so it has both the CPU time and it has both the input output time. Maybe the input output time is more than the CPU time. So the operating system picks and begins to execute one of the jobs in the memory. What is the purpose of the operating system? Even there are multiple programs executing. In your case, it is the that is your text editor, and another case it might be your basically in another case it might be your video watching, audio video graphics driver. So it takes one of the jobs and starts executing. When you are writing, you are writing. And when it is basically watching video, you are watching video. Both are happening at the same time. It takes so what is happening? So a job has two parts. Whenever a job has two parts, it has CPU time also, it has input output time also. So when you are writing a CPU time, you have written something on the Word file, and it has to be stored into the hard disk. So when your data is getting stored into the hard disk, what is happening? That time the CPU is free. That time the CPU is running your YouTube video. Okay. And sometimes if sometimes your what is the video is buffered, right? And the operating system, so it is running as it is, and in the between you are also writing the thing. So basically what is happening, the operating system is switching rapidly between your text editor software and the video display software, right? And it is doing so rapidly, you are not understanding that it is a single CPU system. You know that's a single CPU system, but it is the operating system is switching the job so rapidly, you are thinking that both programs are running on the computer. Have you understood what is the multi-programming system now?
Yes, sir.
Yes, sir.
Anyone, any question?
No, sir.
Okay. So let us say so this is three jobs. Okay, job one, job two, job three. Okay, and let us say the scheduling algorithm is FIFO. Okay, so we'll see what is FIFO and all those things. So initially the operating system does what? It keeps the job one in here. So the processor is working on the job one. So sometimes it might happen the job needs a hardware. So sometimes your data has to be stored into the that is your hard disk. So it goes to the input output key. So it goes to the input output queue. So at this time, your processor is what you can say is idle. So what does the operating system do? It immediately brings another job to the operating system, right? And it processes the job. And when this job to the input output system or the hardware memory is complete, it goes back to the memory, right? And then again operating system goes to job 3, then it schedules job 1, like this it works. So what is a multi-programming system? It allows multiple programs run simultaneously. Okay, in here the operating system allows multiple programs to be queued in the memory, right? And what is a multiprocessor systems? Multiprocessor systems are basically multiple CPUs. Understood now? Bujle?
Yes,
sir.
sir.
Okay, now what is a time sharing system? So time sharing system is a logical extension of multiprogramming. Logical extension means it is same as multiprogramming only, but what does it means actually? It switches occurs so frequently that the users can interact with each program while it is running. Okay, so the job switching between the so if you are working on the processor, so you will have a feeling that you are working on the word text also, you're watching video also. So you are thinking that it's the system is multi-processor system. It's actually not. It's a single processor system, but it allows the switching so frequently that you can real-time interact with each program while it is running. That is what you can call as the time sharing. It is a logical extension of what you can say, logical extension of multi-programming, and it is basically what time sharing, right? It is switching is so happened randomly. So basically, in the real time, you are thinking that your program, you are directly interacting with your program, right? So a time shared operating system allows many users to share the computer simultaneously. Okay. So what? So the question so the main question that comes from the module 1 is these 3 questions. You have to explain what is multiprocessing, what is multiprogramming, and what is time sharing systems. Okay. Now in here we come another type of operating system, that is batch system. So you will be working in basically the lab today only. Okay, I'll just take 1 minute of time or 1 minute of break. I'll come back immediately. Okay, are you all there?
Yes, sir.
Okay, thanks. Now, what is a batch system? So basically, batch means what? What do you mean by batch actually?
A group.
A group, right? So now, when in the case of operating system, we are considering a group of commands or group of programs, right? So in batch operating systems allows batch programs to run. So basically, in what happens? So batch commands are those in direct control those commands to enter into files, and those files are executed. So in a single file only, so in a single file, so in a single program, you are putting the you're writing multiple programs in a single program, and you are putting them in a file. And what happens? You are putting them to run. So it is similar to that. You are writing multiple codes or multiple commands in one single file, and you are asking the operating system to execute them. You will see when you are writing about self-programming, you will see that you are writing multiple programs, and the system is running all of them. So that is all about the batch system is all about. So it allows multiple groups of jobs in processes, multiple jobs in a bulk with predetermined input. The input might be same in all the cases or might not be same, but it allows multiple jobs to be executed at once or being submitted at once. Understood?
Yes, sir.
Okay, fine.
Yes, sir.
Okay, now job scheduling. So job scheduling, we will go into the basically the later lectures to learn about what is actually the job scheduling part. So if several jobs are ready to be brought into memory, and if there is not enough room for all of them, then the system must choose among them, right? So in multi-programming, what happens? You are allowing multiple programs in the memory, and they are working so frequently, and they were changing the CPU, and the CPU switching on them so frequently, you are not able to understand, but you are understanding that your job is only running. Okay, but now the operating system in here, but you may, but sometimes you may see that when multiple programs is running, and sometimes you see that your system is slower. So you are writing something, it is not printing on your Word file, right? But after 1 or 2 seconds, you see all those things that you have written are stored basically in a buffer, and it is automatically being written on the Microsoft Word file or text file. Sometimes it happens, right? বুঝলে?
Yes, sir.
So in that case, what happens? In these cases, what happens? There are multiple jobs, and the operating system has to decide which jobs to be allocated to the CPU. So there are multiple jobs in here, and the operating system must decide which job must go to the CPU, right? So it depending upon the various criteria, I have only discussed about FIFO, but depending upon various criteria, these jobs can be allocated to the CPU. And for that only, there are basically scheduling algorithms are there. So the operating system has multiple scheduling algorithms to choose to allocate jobs to the processor, and these are basically this is done by the this is also called CPU scheduling. Okay, বুঝতে পারলে?
Yes, sir.
Okay, so what are the things that we have learned today? What is bootstrap? What is initializing or rebooting a system? You understood? Any question? Any question you have?
Yes.
না আরেকবার বুঝতে হবে? Do you need to understand again?
No, sir.
There are multi-processing systems are there. Okay, there are multi-programming systems are there. There are time sharing systems are there. There are batch systems are there. There are job scheduling programs are there. And then there is the last thing that we are going to learn today is protection. All right. Protection is any mechanism for controlling the access of processor of users. Now, this protection means what? Supposedly, your computer shuts down automatically. Okay, you have no clue what happens. This is basically what happens. So some processor, what the memory it allocates, it requires much more memory than that. It basically happens when you are writing a C program and you are trying to access a memory that is not allocated to it. Supposedly, so supposedly, if you have declared in a program, you have declared an array of size 10, but you are trying to access memory address of array 11. In that case, what happens? In that case, an error happens, right? So basically, this is basically the so in that case, if that error happens, so operating system tries to protect the system by shutting the system. So what is the basically protection is basically about? Protection improves reliability by detecting latent errors at the interfaces of components of systems. That is one thing, or the resources defined by a computer systems. So this happens because there are two processes. One is basically working on the printer, another process is working on your C program, and somehow one process tries to access the memory of other, then the error has to be resolved by the operating system by shutting the system down. So these are the mechanism that is followed by the operating system. Another job is the use of security. Now the part of the security is to defend the system from external and internal attacks. External attack means some hacker is trying to access your information within your desktop, right? So what it does, it types your IP address, it knows your user ID password, it gets in the system, and it takes or it steals your account information, all those things. It can happen. So basically, it can be viruses, worms, denial of service attacks, theft of service attacks. So these kinds of attacks in generally happens from the internet in your system, right? And this results in the basically the corruption of the operating system, right, or corruption of your system. So the operating system allows multiple security protocols are there which defends your system from such attacks. Understood?
Yes, sir.
Okay. Every one of you understood?
Yes, sir.
Yes, sir.
Okay. So you can give your roll number right now. We'll stop the class. So you study this one. We'll be asking some questions. We'll be giving you some assignment later. ये अटेंडेंस लिख ले चैट बॉक्स से अटेंडेंस दो चैट बॉक्स से okay. Okay, thank you. So today's class is over. So maybe some in 2 or 3 days. So let us go into the module. We'll be giving you some questions. Right. Okay, thank you. You can leave.
Thank you, sir.
Sir, today we
Thank you,
have
sir.
another class, right? Sir,
হ্যাঁ কি বলছো?
আমি বলছি আমাদের আরেকটা ক্লাস আছে না আরো
হ্যাঁ
মানে
ল্যাব আছে
ব্রেক